Por favor, damos un aplauso a nuestro siguiente ponente.
Buenas tardes, mucho gusto. Voy a probar esta, sí, mejor creo. Bueno, mi nombre es Sven, yo vivo aquí en Bolivia hace 2 años. Manejo español bastante, pero en realidad mi idioma nativo es sueco. Y en realidad charlar sobre estos temas en sueco para mí es también un desafío, porque el vocabulario es en inglés. Perdón. Entonces voy a hacer mi charla en inglés. Pero podemos hacer tal vez preguntas en español después. Y voy a hablar sobre el tema de seguridad de aplicaciones de web. En este punto voy a cambiar idioma. The intended audience for this presentation is really anybody who works with development of web applications, or if you're involved as a coder, if you work in a development team, or if you work as a product owner, or if you work as a tester, or even somebody who's ordering the work of making a web application. You should have some idea of what is the responsibility of the team actually to work in terms of security awareness, and not just take things for granted. You know, there's a saying, assumption is the mother of all screw-ups. We shouldn't just assume that people are writing secure code. We should try to communicate what assumptions we have on a team that's working for us. And also, if we belong in a development team, we should communicate our own ideas about this. And this is varying a lot among different teams. Some teams has a wider responsibility, some teams has a more narrow, but we should try to define a baseline. That's why I call this a baseline, because like a minimal set of routines we should work with in a development team. So when I talk about this topic, HTTP application security, I always want to get one thing out of the way first, okay? And it's the idea that securing HTTP, we're talking about applications over HTTP. Isn't that just about appending an S? HTTPS, S stands for secure, doesn't it? Are we safe if we're just serving our applications over HTTPS? Well, so let's just do a recap of what we actually know by using HTTPS, and what we cannot assume in terms of security. What we're doing is, of course, we're tunneling the HTTP protocol over an SSL channel. So we're communicated over an encrypted channel, which we have to do on an insecure infrastructure like the internet. However, so nobody who eavesdrops the communication will actually be able to read it if our encryption schemes work the way we expect. Okay? However, we know something more. The server is presenting a certificate to the client, and the certificate is signed by a certificate authority, and this certificate authority is trusted by the client as well. So there's a trusted third party involved. Gracias. And this gives a certainty for the client to know who he actually is communicating with. And this is called domain validation. And we can also have extended validation. We can also give the client a certainty that the server who's in control of the server not only owns the domain, but also is a legitimate business. That's called extended validation. So there are certain types of extended attributes we can have. So that's pretty much what we know. Yeah? And there's no use case for communicating over an encrypted channel if you don't know who you're communicating with. So we really need this third party, this common trust in a third party for this to be effective. And if we combine that with some sort of authentication for the client, it can be built in the HTTPS protocol. We can use client authentication or we can use password. Then we have a mutual certainty of identity. Okay? So both communicating parties have a certainty of each other's identities, and we're also communicating over an encrypted channel. But that's not really security. That's not a holistic security, because we might need the application to be open, or we might not have total trust in all our clients. For example, an internet bank, only because you have enrolled your clients in a stringent way, it doesn't mean that you trust all the clients. So a lot of things can go wrong. Accounts can be compromised, and so on and so forth. So we need application security too. We need our application to be secure against the common attack vectors and vulnerabilities. And I'm going to go through this very briefly. Maybe we can get back to it a little bit in the end if we have time. So the first one, XSS, cross-site scripting, is something that every developer, everybody who works with web applications should repeat this a little bit from time to time. You need to refresh your memory of what these attacks really are. And cross-site scripting is really the grandmaster flash of web application attacks. So it's a big category of attacks, and it's divided in subcategories. And whenever you're communicating with somebody, you have a trust in that party you're communicating with. If I'm, for example, if I'm browsing to my internet bank, cross-site scripting is an attack that exploits my trust in the server or in the service that I'm using. So I'm browsing to my internet bank, and my internet bank is presenting an HTML page, and it's presenting scripts that makes my page responsive. But if there's something, some illegitimate scripts running on my page, if somebody manages to inject some scripts running on my page, that's cross-site scripting. And there are different ways of doing it. There's 3 categories. There's reflected cross-site scripting, persistent, and there's DOM-based. And the DOM-based category is the most nasty one to defend against. And we can get back to that if we want to. CSRF and clickjacking, I can just mention those because those are not anymore on the top 10 list of the most frequent attacks. They have been deployed a very good defense against those attacks all over the internet, in terms of attributes that you set on cookies, in terms of headers on the HTTP protocol. But we need to assert that we're actually using those sort of protections. And for example, cross-site request forgery, every time we construct a form, we use with the web application framework, and we construct a form, there's usually a built-in protection against CSRF. And your go-to resource for this sort of attacks is the OWASP top 10. So if you work with this or want to get a bit more proficient in these different types of attacks, that's where we go. When we actually want to find out what countermeasures are we going to use? What are we going to do to protect ourselves, our application? There are lots of different aspects to this. It's a big landscape. In order to find out what we're going to do, we can ask some experts. Yeah, we should check with the experts. So I've actually put together some different takes on this topic, some different answers from different experts, and this is fiction, but it's quite typical, at least in my experience. For example, if we talk to a product vendor, how are we going to secure our application? Well, you can deploy it behind our product. We have a reverse proxy or a web application gateway, and we're actually adding security to your application. Fantastic, sounds great, and it is great many times. However, it's not the end of the story. It's too good to be true. And a pattern for building security is really building in security. It's not adding on security afterwards. We really need to include security in the application as well. Hosting environment, also very important, and you can do a lot with hosting environment. You can deploy different sorts of monitoring functions and intrusion prevention and so on. It's the same thing. It's like an add-on, and this is one of the things that different between different teams. Some develop as a development team. If you have if your task is to develop an application for somebody, sometimes perhaps you're also advising your client on hosting. It's part of your responsibilities. Other times it's not. You're just delivering a WAR file. You're not really involved in the hosting process. But the takeaway from this is that you should make that relationship clear. How far does your responsibility stretch? You shouldn't just make assumptions about it. We can also ask, information security people about this. Oh, I love PowerPoint. Let's see. Let's see if I'm trying to go backwards. No. Forwards. Nothing. Do we have... Do we have some technical support? Here we go. So, we can ask information security experts about this. And for example, this woman has an interesting take. Do you protect your assets, your own information assets in your development team? How do you work with your source code? Do you protect it? And do we sign our code? And do we protect the integrity of our code? Because not only as a development team, we can't just be concerned with the traditional interfaces for attacks, for web attacks. We need to also make sure that our own process doesn't leak information. That's definitely our responsibility too. And it depends, of course, how big the team is and what sort of processes you have in the team, how critical this aspect is. But and even worse than leaking information, what about being exploited, being a vector for malware? If you remember Petya and WannaCry, the big ransomware epidemics like 3 years ago or so, one of them was actually induced by a product company, in Ukraine who were delivering a product. I think it was called Medog, and it was actually the seed that spawned this really turned out really costly and very, very bad epidemics. So you don't want to go down that way, have your being out of business. That's a bad way to get out of business. So it's a good point. So these are sort of like peripheral takes on web application security. What about if you ask the development team? We have lots of different, of course, different levels of proficiency and different attitudes towards security in the team too. For example, like this guy, security. That's not what I do. I build features. I make the application do things. I'm not a security guy. And that's bad. That's not a responsible attitude. So we want to get this guy on board also. We need to get this guy on board with security. The next guy is much better. He knows what he's doing. You know, he knows that he's using frameworks that patches vulnerabilities, and we can't be exposed to SQL injections and stuff. And he even knows that we have there are dependencies that might have security flaws that we need to patch and so on. And he's proactively doing things like this. And the third guy too, also very proactive, but he's an expert. He has a certain topic. This guy is into cryptographic strength, and he's tightening up the cryptographic strength as in the application. That's great too, but it's a bit arbitrary. We don't really know. Can we really trust just because we have good developers that they're doing the right things, and exactly those things that they're doing are the things that need to be prioritized? And this is really what I want to get at here. We want to find the baseline with a set of things that we need to prioritize. And this fourth guy is onto something. OWASP secure coding practices. That's great, we have a standard. But maybe just handing the OWASP secure coding practices to the development team is overwhelming for some developers. It's a little bit too much for the guy on top here. You know, maybe he won't know what to do just because you hand him a document. So there are different roles in the team and different attitudes in a typical development team. Yeah? So we might also have a product owner, and a typical response for the product owner would be like, well, I instruct the team to follow these secure coding practices. I give them this document and I expect them to follow it and to deliver secure code. Sometimes that works, sometimes it doesn't. You know? A security tester, perhaps running penetration tests on the application. I can run a vulnerability test on the application, and then I get an output. I have a fantastic testing tool. I can scan the application, and I will get a list of vulnerabilities. Perfect, and I just hand the list to the team, and I give them 2 weeks, and I expect them to give me green light or a thumbs up, and then I test again, and I expect all the vulnerabilities to be gone. That's great if it really works that way in practice. However, the problem with these two attitudes also is that if you just hand the team a bunch of documents and you don't follow it up, you don't have a process to know that the team are actually working against those criteria, then you don't really know what's going on. The same thing with the vulnerability test report. It's a long list of vulnerability, and actually running a vulnerability scanning, that's the easy part. The difficult part is going through the list and identifying false positives, because when you're testing your application with a penetration testing tool, you will always get false positives, and you need to identify those, and then you need to follow up the test. So you need to, in both cases, you should wrap this thing in some sort of process where you control it. You should have some sort of responsibility and some sort of process. And I'm a big fan of running security tests. I think it should be incorporated in the release cycle. You should do it regressively, so that that's one way of discovering new vulnerabilities. Yeah? But you have to do it the right way. So after collecting all this information from all these different people, we can start looking at the whole landscape of countermeasures in terms of web application security. So therefore I have made this model with different boxes. So if we have already seen that information asset handling is important. We need to know how to have a good control of our sensitive assets that we handle in the team. We need to we need to have good infrastructure. We need to harden the platform and the application. And of course, we need to write secure code. That's like the core responsibility of the team. Nobody can deny that. We need to monitoring our dependencies, because we're not only delivering our own code when we deliver our application, we're delivering lots of dependencies, and we need to monitor those and know when there are known vulnerabilities and patch them. And we might have a lot of integrations that we need to secure. And we need to think of our quality of designs. For example, we shouldn't invent too much when we build software. We love to invent stuff. It's fun to be innovative, but we should try to hold that part back a little bit and use well-tested design patterns. But the more you invent, the more you also have to scrutinize and test your own designs. So, for example, when you have a web application, there should be no way that an unauthorized user can start to exhaust the memory of the application, for example, or use your login mechanisms to lock out other users, or use your login mechanisms to even test and verify are these particular email addresses in the system as users. So all such things you also have to scrutinize. And it depends very much about, it's hard to generalize about this, because it depends on what sort of application you're building and how innovative you have to be when you build the application, how much you can use standards, standard stuff, and like framework implementations. And then there are processes and specifications and compliance. I put them a little bit beside the rest, because they're not isolated as the rest of the building blocks here. They're not isolated in terms of activities. Like a process might span over all these other building blocks. But they can be isolated in terms of responsibility. Somebody can be responsible for processes. Somebody can be responsible for specifications and so on. So where do we get guidelines in all this big landscape of things that we could do to improve our security? Well, there's lots of frameworks. Regulatory frameworks. We might need to follow some of these frameworks. If we build, for example, something that's used in healthcare in the US and perhaps in other countries as well, it's the HIPAA. We need to be HIPAA compliant. So we actually have a regulatory framework that regulates things that we need to do. And in Europe now, many people who develop applications are affected by GDPR and so on. So there might be frameworks regulating what we need to do, and there are also some more practical activity-oriented frameworks like the OWASP and control frameworks. But then, how much should we apply on all these regulations? How much security shall we have? Can you have too much security? And the answer is yes, you can. We should not, the principle here is that you shouldn't spend $100 to protect a $50 bill. Like the theoretical answer is that we shouldn't spend too much. We should just spend just enough on security. And the way to approach this in many fields is to have some sort of asset evaluation. We try to evaluate how much is the data in the database actually going to be worth, and what are the consequences of actually having a security breach. So having some risk management in place. But in a typical development team, we don't have that. Especially not in a startup. We have a job to start building a web application for somebody. We don't have risk management. We need to have some other guiding principles. What we always have is professionalism. We should always be guided as professionalism and our sense of responsibility. So I want to go back to this model again and try to find a baseline. What are the things we always need to be responsible for in the development team? And I'm starting right in the middle. Writing secure code, of course. There's no way we're going to be able to say to somebody, that's not our responsibility. We were never told to write secure code. No way. We have to write secure code to the best of our ability. The same thing with monitoring our dependencies. We're using third-party dependencies, libraries when we develop applications. But we have to be responsible for whatever we send to the customer and try to monitor those as well as we can. And that's a very, very important task that is often overlooked in many teams. And the same thing with the application configuration. We deliver our application with our source code, but also with configuration files. And we are responsible for those configuration files if we build a web application. So this is a good baseline for you also if you order a web application. If you want to check with the team, are these guys actually delivering something that is secure? Try to ask them about these topics. How do you implement like dependency handling? How do you ensure that you write secure code and that you're hardening your configuration? So I actually shaded also the secure architecture block here, but it's very difficult to generalize about that because I think I renamed it from the previous slide also. I called it securing our implementations or something like this. It's more a moving target. It's more difficult to generalize about and to isolate in terms of security activities. Okay. So what we can do when we start to divide and slice the security domain like this is that we can assign responsibilities. One thing that I keep coming back to when I talk about this is processes. We need to have processes in place. However, in an agile team, we typically want a quality that's called self-organization. We don't want to work with too many processes. And an alternative to being process-centric is to be role-centric, to actually assign specific roles to specific people. So in this little experiment here, we have our 3 developers, and we're going to give them one area of responsibility each. This guy is, or it can be a girl obviously, also is responsible for hardening the configuration. That's your responsibility. Make sure it's done. And teach the other in the team about it. Tell them what you're doing, you know. And the other guy writing secure code. That's something that everybody should do in the team. Everybody's writing code. But one person can be like, can have a bit of responsibility about this. Normally, perhaps you have a peer review in a development team. You have a peer review process when you're reviewing each other's code, and teach the other team members of secure coding practices. And the same thing with dependency monitoring, which is the third area of responsibility. I'm just going to check the time here. Okay, so this is actually my 3 lines of defense that I would suggest to use as a baseline if you want to increase security awareness when you're building web applications. And let's start looking at these things in a bit concrete terms. Now I'm going to get a little bit more technical in this talk, but not too much, I think. I hope. So you have to be able to answer these 3 questions with a yes. And this is actually something you could ask somebody who's building a web application for you too. You know, will you get alerted when there are dependencies in your application that has known vulnerabilities? Will you get an alert? And does that alert cover all types of dependencies that you use? Are you using NPM dependencies? Okay, great, you're getting alerts from some service that you're using. I'm going to get back to that later, how you can implement this. Does it also cover Java dependencies that you might have in your backend? And do you have a plan for how to respond on those alerts? When you know that, we have a vulnerability here in this library. We're using a library to create PDF documents. And now there's a known vulnerability. How do you respond? Do you have a process for patching it fast? And when it comes to open source dependencies, the principle is really, well, we can deduce it from Linus Torvalds law, given enough eyeballs or bugs are shallow. The principle is really that the information shall be shared. Lots of people all over the world are reviewing and looking at source code, and when there are known vulnerabilities, they share the information to as many people as possible, and that's how we can stay secure. This is the principle we use. So let's see here. There are lots of services we can use to get alerted. For example, there's a dependency check service from OWASP. There's a whole range of other, these are really vulnerability databases and vulnerability services that you can use. Some of them are free to use, some of them are proprietary or semi-proprietary, but all those that I wrote on one line here, NIST NVD, which is an American government initiative, and all the ones following on the same lines. For example, GitHub has built-in dependency monitoring. They all more or less use the same databases, at least partly. So they all share information, and that's great. We should not keep this information secret in the open source world anyway. And there's something called Retire.js and SNCC. SNCC is a very nice service. You can use some of the simpler interfaces to SNCC for free, and it aggregates dependency information or vulnerability information from many dependency databases and from many types of dependencies like Python, Java, Ruby gems, or what it may be. Okay? So this is how you implement dependency monitoring. You implement it with automation. You subscribe to this information from some service, and you use it as part of, for example, of your build pipeline. And all developers love to do automation, so you can easily recruit the guy who wants to do this, and you should, at an early stage in every project. He's happy, he's smiling with his big braces. What about writing secure code? Well, this is also something that you can assign somebody to be like the grandmaster, to be a little bit responsibility that this is implemented in the team, if you have a peer review process or something. And again, OWASP is the go-to resource. There are lots of things you have to do in terms of keeping your code secure. You have to look at your error handling and how you connect to databases and files and so on. Memory management. There's something that can be generalized a little bit more also here. One aspect of secure code, and that's input and output data handling. How you actually treat the data that somebody feeds, for example, in a form, in your web application, and the data that you print to the interfaces. And that's of course a very, very big and very important part of writing secure code. And the first advice to master this subject, because it can be confusing, especially for new developers. There are so many terms around, like validation, whitelisting, blacklisting, sanitizing data. What the hell is sanitizing data or encoding data? Is that what we should do? There are lots of terms flying around here. So the first thing to master this is really to learn the terms, to learn the definitions. And then it becomes much less complicated. Input data should always be validated, and it should be validated against a whitelist in every case that you can. You should avoid blacklisting. You should be as restrictive as possible with the data. And whitelisting actually means that you're looking at each character. Somebody feeds a phone number in your web application form. Then you look at each character, and you have a list of approved characters. So, for example, the numerical characters, obviously, 0 to 9. Maybe you allow dashes. Maybe you allow plus if you want to allow exit codes and country codes, and maybe allow spaces, and that's it, nothing else. You know, that's your whitelist, everything else should be rejected. And that's the way you should implement it whenever you can. Try to avoid blacklisting. Try to avoid trying to list everything that is malicious or potentially dangerous, because that's a hopeless task, and it has to be maintained forever. Sanitizing is when you actually replace something in your input. For example, if you accept phone numbers in different formats, and you want them all be exactly the same, so you want to remove country codes, for example, then you're sanitizing your data. But the good guidelines here is to always be as restrictive as possible, of course, and try to keep complexity down. Don't invent the wheel. You know, try to not do too many inventions in this step in your data flow. And you should consider all the inbound data sources. For example, if you're receiving data from forms, that's not perhaps the only data. Any potentially user-supplied data that affects the way your application is running. So it might be HTTP headers. If you have dependencies on HTTP headers, you need to validate those. If you have dependencies on query strings, you need to validate those. Everything that can be supplied by a user who might have a malware installed, who might be tricked to supplying this, should be validated. And you should take special consideration if there's any data arriving in your application and that is directly affecting the DOM. That, in other words, any data that is directly affecting how the page is rendered, or that manipulates a href attribute or something. So anything that is not going back and forth on the server is actually more sensitive, counter to perhaps many people's instinct about this. Because the most tricky category of cross-site scripting attacks are really DOM-based cross-site scripting, when we don't round-trip data on the server. And OWASP has a special cheat sheet that we should use and have a look at when we have these particular cases. So these are good guidelines for our inbound data. What about outbound data? Well, when we're talking outbound data, that's when we're talking about encoding. And so there are two concepts we need to learn about outbound data. It's encoding and context, the outbound context. Where are we actually publishing the data? Are we publishing it as HTML attribute, as HTML content, and so on and so forth? That's context. And there are other contexts also, except for outbound interface data. There might be, for example, we're writing data to an SQL database or to an XML file. Those are different contexts and require different sets of escaping. And escaping, we should never, encoding. We should never implement encoding ourselves. We should always use frameworks. We should always use libraries that we know are up to date for the specific context. And we have good guidelines from OWASP also regarding this. So I'm going to talk a little bit about, now let's see what the time is. Yeah, we have some time. The topic of your application configuration. This is something that is very, very easily overlooked. There are many teams that are actually forgetting about this. And the reason is that many teams have a good process for peer reviewing. Whenever they write features, they review each other's features, and they review the source code. But we don't only deliver the source code, we also deliver configuration. And this needs to be hardened. And there are lots of things we need to do in the configuration files. Like we need to implement enforce password policies, cipher strength, disable insecure protocols like clear text HTTP in a production environment. And a lot of developers tend to think of hardening as something that is done by the DevOps or those who host the application. But part of it is definitely responsibility of the development team, because the configuration files are our assets that we are responsible for. And a big part of this is restricting the HTTP protocol itself. The HTTP protocol itself is like a big toolbox. And one way of looking at it is as a hacker's toolbox. It contains all sorts of cutlery and tools, and we want it to contain only a specific spoon and a specific can opener that the client needs for us to feed them our can of dog food. Nothing else. I don't know if that's, I think you get the point, even if it's not a good metaphor. And one thing of doing it is actually restricting the methods in HTTP to only the ones that you use. And the other one that many developers don't know about are HTTP headers. Or many developers know too little about it. The HTTP payload is always preceded by headers that are telling the browser how to use this particular endpoint, what is allowed, what is disallowed. We have a lot of examples here. Some headers are prefixed by an X, and that's a hint that this used to be a proprietary header, but it's nowadays it's a common standard header. In this case, we have something. The last one is called CF-Ray. That's a proprietary header. That's something that Cloudflare uses for tracking the traffic. We have the server header that identifies the actual server. And the security headers are pretty much these. We have three relatively new security headers. The CSP, Content Security Policy, is the one that all developers really should know about and always make sure that you have it. You can just view in the browser when you're browsing your application, make sure that it's there, because it's used to mitigate the big traditional classes of cross-site scripting, the reflected and the persistent ones. It can't really do so much about DOM-based cross-site scription, so it's not it's not the end of the story. Okay. We have HTST, expect CT. Those are headers that can for example, HTST is patching a vulnerability in an old pattern. Lot of web application uses redirect. If you browse them on HTTP, they redirect to HTTPS with a response code 301. And that's really, there are actually intrinsic vulnerabilities in this pattern. It's better to use the HTST header, and so on and so forth. And all those that are prefixed with X are antique headers. We should still use them to support older browsers. And our cookies, the client and the server are communicating cookies back and forth. The server is using a header that's called set cookie. There are lots and lots of security attributes we need to know, we need to use in our security header to mitigate. This is one of the reasons, for example, the same site attribute here is one of the reasons why cross-site request forgery is so successfully mitigated nowadays. And moreover, caching. We should control how our data is cached in the browsers. And there are some headers we should not use, or we should be very careful with using them, and those are the course headers. Course is the process of overriding something called same origin policy. which is a policy for how a web application can consume data from different other endpoints on the internet. So this is a good list. Go through this list. This is a big responsibility of whoever is in charge of an application configuration. Oops. So the takeaway from this talk is really this. First of all, try to bring up this image again of this activity-based model that I outlined. There are so many different aspects to web application security, and try to define how far does the responsibility stretch in your team.